So in this very brief video, I'm going to be covering the idea of a perpetuity. It's basically an annuity that has no fixed end time, it just goes on forever. A prime example of this is dividends. So if you hold, let's say, preferred shares in a company, they will pay you dividends, and as long as you hold that share and the company does not go out of business, that is technically a sort of endless stream of payments that you can potentially get. So I'm going to show you how to calculate the present value and the future value of a perpetuity. Let's start with the future value. So let's say you have a timeline, and I won't draw it in, it just goes on forever, and this represents time 0. Let's say you get paid a dividend today, or get some sort of cash inflow today of $2. And you're going to get that every year. And since it goes on to infinity, it's never going to stop. So you're going to keep getting $2 sort of forever, as long as you're holding the stock, or it's as sort of the money keeps coming in, is what the point is. So the future value of this is, you might have guessed it, is infinity, because you sort of find the future value of all this money and it goes on for infinity. You're going to keep getting cash inflows indefinitely. So there's no end to them. So the future value of the money you're going to have in the future is sort of infinity. On the other hand, the present value is what usually confuses people, because students usually seem to think you can't quantify a number that goes on forever. I mean, if it goes on forever, then your present value is going to be infinity too. Well, not really. So the sort of formula for calculating the present value is the payment over the interest rate. So let's say I'm getting paid $2 for forever, and the prevailing interest rate is, let's say, 2%. So your present value, you just have to plug into here, $2 divided by 2%, and you'll get your answer. But the reason this works is because you are going to keep getting $2 up to infinity. But to actually calculate the present value, you are discounting each cash flow back to time 0. So you're going to discount this back 1 year, this back 2 years, this back 3 years, and you keep going. The problem is, as time goes by, let's say 50 years from now, you try to discount back $2, you'll get something like 2. And this is the present value of just a single lump sum. You'll get 2 divided by 1.01, which is an interest rate, to the power of, let's say, 50 years from now. If you actually do this math, this is going to be an extremely small number. And imagine 100 years from now, it's going to be even smaller. So as the time approaches infinity, you are getting money, but discounted back today, it's so small. Each payment discounted back becomes so small that we sort of neglect that, and it's negligible. And this is how we get this formula. There's a way of deriving it, but that's not really important for the purpose of this class. It's important to understand that in the future, your money is going to be infinity. Discounted back, though, you can find a finite value for it using this formula.